Well, here's a nice simple presentation of the base station. As we know, it is called the G node B. And being a base station, well, it does base station things. The most obvious thing it does, of course, is provide the coverage. As with any radio system, there'll be a series of antennas and radio emissions that supports radio coverage, and specifically the NR. Now, the new radio is all different and new and has a lot of capabilities in various dimensions. But in the end, the base station is a base station. It does base station things. So radio transmission reception, certain amount of baseband and digital signal processing, whether that's modulation encoding or antenna processing. It supports the access stratum to the UE. In other words, the RRC, the radio resource control across the radio interface. It provides a relay between the mobile and the core network for non-access stratum signaling. So out here somewhere there is a core network. And remember that this could either be an EPC or it could be a 5G core network, a 5GCN. Okay, so that non-access stratum signaling may be 4G or 5G. In either case, the 5G G node B will simply provide a relay function for that signaling. It does radio resource management, which is somewhat related to radio resource control, although there are other aspects in there as well. And this being a modern mobile network, the base station is able to communicate with its nearby base stations as well. So like we saw with LTE, where we had two base stations interconnected with what's called an X2 interface. We can do the same thing here for different reasons, not entirely different reasons, but some new reasons. But that interface, as we'll see, is referred to as the XN interface. But the principle is the same. Now, what we're looking at here, of course, are a logical picture of the various interfaces that we might support. For sure, we have to show some kind of logical presentation of these interfaces. So we know that a base station has either an S1 or an NG point-to-point connection with the core network. I mean, that fact is true. S1, of course, being the 4G and NG being the new one for the 5G. Notice on this picture, we haven't actually labeled the base stations. They could be either 5G or 4G, which is why those interfaces are labeled as both S1 and NG. The better way of drawing this picture, however, is to draw the transport network as its own cloud, okay, and to have the base stations, in fact, connected more like this, because it is, after all, a network, and there will be a connection here back towards the core network. So this is the NG something interface. And then what's inside of this cloud then are all of those interfaces, but it is a networking infrastructure. It is an IP-based networking infrastructure, meaning that each of the base stations hanging off this cloud each has their own IP address. So from an internal network perspective, information can be delivered from the core network to a specific base station by knowing what its IP address is. Now that sort of hints at the fact that in here there will be, at least in the transport layers, so down there in the sort of lower parts of the protocol stack, there will be routers, there will be IP routers. So we can deliver information to a base station on the basis of its IP address. That IP infrastructure that's across here is a private IP domain. It's got little or nothing whatsoever to do with the end-to-end exchange of IP, which if I have a mobile, which is indeed sitting here, and it's exchanging IP traffic with the internet, say, then that mobile is exchanging information with the server on the internet, again, based on a set of IP addresses. But that IP flow that we have here has got really nothing at all to do with the IP flow across the access network. So we encapsulate the packets using GTP, and then GTP is then inserted into the private IP layer, and that's what gets it to the base station. When the packet arrives at the base station, of course, we unpack all that stuff. We rip off the IP. We find the GTP header. We figure out which mobile or data radio bearer this belongs to. We can throw the GTP header away. And then we can start the process of transmitting the IP packet across the radio interface. But the base station itself is not an IP router for the user packet. There is a different process going on there. We have a radio bearer, or a data radio bearer, which is known to the base station, and that is mapped to a GTP tunnel endpoint identity in this part of the network. So there is a breakpoint there. Tunnels here, data radio bearers on the radio interface. The access part of the network, or the transport part of the network here then, It's much better to think of it as a network like this into which we will map these logical interfaces. So as the picture shows here, let's draw a logical line through here. That would be my NG or S1 interface. We would also have, as shown by the inter-base station interfaces here, an X2 and an XN. Now, it's far too easy just to draw a line between two base stations and call it done. Now, practically speaking, we're almost never going to do that because an X2 or an XN interface has to come back across whatever this interface is, has to come back into the network to be routed back out here. Right, so that would be, again, it's not particularly practical, but that's a better representation of what an X2 or an XN interface would look like. Similarly, if this middle base station here, and we have base station B and we have base station C. So now to connect base station A to base station C, well, guess what we need to do? We need to route it into the network. It needs to go through some sort of routing process and then come back out. And that would be the X2 or the XN interface between the A base station and the C base station. I mean, that might be entirely obvious to you because this is pretty much what an LTE E-UTRAN would look like as well. It's not, at least for the immediate time, it is not going to be necessary for you to completely update or completely replace the existing transmission network because, you know, the fiber you've got in the ground, the microwave links you've got overhead, the whatever physical transmission resources you have in the ground at the moment to support 4G, well, you're going to use the same network to build your 5G on top of it. The only difference being really is that when you suddenly get to the point where you want to plant a new 5G base station in the ground, so now you've got a G node B, albeit a secondary G node B, that then has to be linked into the rest of the network. It could be a new 5G function at an existing site, or it could be a brand new like access point that you've deployed on a street corner, hanging it off a lighting pole or something like that. That then has to be sort of brought into the infrastructure with its own named logical interface, X2, S1, NG, whichever, depends on which one of those options that we're actually looking at. There are functions in the core network here, namely the AMF, the Access and Mobility Management function, and maybe more so, the Session Management function that need to exert control over the base station. Tell the base station what to do. Tell the base station how to manage certain quality of service flows with respect to a particular user. So the S1NG interface allows us then to allow the core network to exert control over the base station. Similarly, the base station may report certain things into the network about the activities of the mobile, their availability, their request for resources, their capability may be reported by the base station. And of course, the relay of that signaling stuff, so the relay of non-access stratum signaling, and as far as the user plane is concerned, delivery of information into the user plane. The solid lines in this picture, so these solid red lines, that implies user plane, and those will all terminate into the network at what we call the user plane function, otherwise known as a router. The X2XN interface, once again, similar kind of functions here. During handover, it's quite a useful interface because there is a preparation and an execution phase of the handover where the X2XN interface is available. We can do some of the preparation signaling before we actually execute the handover itself. That's quite useful. It is particularly useful, maybe even essential, for the exchange of signaling and traffic where there is dual connectivity being supported by the system. Now, that's quite important because if we were to say that this was a master E node B versus a secondary G node B, there is a mobile in some location which is able to communicate with both the master and the secondary. And of course, that is a dual connectivity case. So each of the options that we looked at before, they're all cases that can support dual connectivity. So whether it is the delivery of signaling information between the base stations or user plane information, the XN interface, at the very least, becomes almost an essential interface to support dual connectivity. You could get away with building an LTE network without the XN. You didn't need it necessarily. It was useful to have nonetheless. But the XN interface, in support of those various combinations, those various options, almost becomes a mandatory interface.